Hello everyone, welcome to a session on soaps and detergent. In our home, we are using a wide variety of chemicals for different purposes. One of the major class of chemicals we are used in our home is soaps and detergents. These are used for washing purposes or cleaning agents. As cleaning agents. First, we are going to discuss about soaps. Soap is a sodium or potassium salt of long chain fatty acids. Soaps are derived from fatty acids. The major fatty acids used for soap production is stearic acid, palmitic acid, oleic acid. So soaps are sodium or potassium salts of these long chain fatty acids like stearic acid, palmitic acid, oleic acid. So one of the example for soap molecule is sodium stearate. Sodium stearate is the soap molecule which is formed from the fatty acid, stearic acid, and it is the sodium salt. So soap is sodium stearate. So soap molecule consists of two part, that is one long chain hydrocarbon part and another part is head part, it is ionic part. Soap molecule have two components. One is ionic component, that is head part of carboxylate, that is salt part, that is COO Na part, and the hydrocarbon part is non-ionic, that means it is insoluble in water. So soap molecule have a special structure. One part is one end is water soluble and one end is water insoluble. This property helps for the cleaning action of soap. So these are the examples of soap. We already discussed one example, that is sodium stearate, that is made from the stearic acid. Another example is sodium palmitate. Sodium palmitate is made from palmitic acid. Palmitic acid is a fatty acid. Then another example is sodium oleate. Sodium oleate is the soap manufactured from oleic acid. Then next we are moving to the soap manufacturing process. Soap manufacturing process is known as saponification. We already heard the term saponification. It is the process of making soap, or it is the hydrolysis of fats or oils with alkali. Saponification is a reaction between fats and oils with alkali. This is the manufacturing process for a soap molecule. So soap is manufactured by the reaction between fats and alkali. Usually the using alkali are NaOH or KOH. If we are using NaOH, we will get sodium salt of fatty acid. If we are using KOH, we will get potassium salt of fatty acid. So this is the reaction. A fat or oil reacts with sodium hydroxide to form soap and glycerol. Glycerol is the byproduct which is obtained in the soap industry, soap manufacturing units. Then moving to the different types of soap. There are a wide variety of soaps are available in the market. The major class of soaps are toilet soap, washing soap, transparent soap, medicated soap. There are different types of other soaps than this four category of soaps. First, we are going to discuss about toilet soap. Toilet soaps are potassium salts of fatty acids. These are used as the bathing soaps. So these soaps are made by the saponification of higher grade or best quality oil or fat with calculated amount of alkali. This type of soaps does not contains free alkali, so it can be applied to our skin. It is does not harmful to our skin. Also, this produces soft lather, and this is more expensive and soft in consistency. Mainly, these soaps are used as bathing soap, then liquid soaps, as shaving creams, etc. Then moving to the washing soap category, these are called hard soaps. Toilet soaps are known as soft soap. So lather produced in washing soaps are hard. This is used for the washing purposes. It is made by the saponification of cheap or low grade oils with caustic soda. These are the Sodium salt of fatty acid. Toilet soaps are potassium salt. That is the difference between toilet soap and washing soap. Washing soap is cheaper compared to toilet soap, and toilet soap contains higher grade perfumes. Washing soap does not contain higher grade perfumes, and washing soap is applied to clean clothes. Toilet soaps are applied to our skin because it does not contains alkali, but washing soap contains free alkali, and it cannot be applied to skin. It will be harmful to our skin. Then moving to the next category of soap, transparent soap. Transparent soap are a particular type of soap which contains more glycerin content, or it have a high solvent content like glycerin or alcohol. That is why these soaps are called transparent soap or glycerin soap. This transparent soap is less drying than the normal opaque soap, and this contains an additional oil. Here soap molecule is dissolved in glycerin or alcohol like solvent. That is why the glycerin content is high in transparent oils. Sorry, transparent soaps. The next category of soap is medicated soap. Medicated soaps are soap which contains any antibacterial agents as additional component. This is used as a medicated soap. This includes the soaps we are used like Dettol, Savlon, Neem. All these categories belongs to medicated soap or antibacterial soap. It can kill or prevent the growth of microorganism. That is why it is termed as medicated soap. Other than this four category, there are wide variety of soaps are there. One of the categories baby soap, which is applied to our babies, which is baby skins are highly sensitive and soft, so the oil must be highly pure, or higher grade for the preparation of this type of soap. Another types of soap is calcium soap or magnesium soap. Usually soap is the metallic salt of fatty acid. All the metals can form soap with fatty acid, but the sodium or potassium salts are only used for washing purpose because these salts are soluble in water, but the calcium salts of fatty acids and magnesium salts of fatty acids are insoluble in water, so it cannot be used for the washing purposes. These types of calcium, magnesium, or lead type soaps are used for other purposes like as lubricants and dryers in paint industry and waterproofing agents. So these are the different category of soap we are using. Then we are moving to the cleaning action of soap. We already discussed soap have a special structure, that is soap has two ends. One end is ionic end and one end is non-ionic end. That is long hydrocarbon part of soap is hydrophobic, or it is water insoluble and insoluble in organic solvent. The short ionic part, that is head part is COONA plus, is hydrophilic and it can soluble in water. So this is the working of measles. The cleaning action of soap is due to measle action. Before we discussing the cleaning action of soap, what happens when oil and water mix together? If we mix oil and water together, it is settled down as two layer, that is one oil layer and one water layer. It cannot be interact together because of the interfacial tension. If we add soap molecule or soap solution to it, what happens? If we stir the solution, the oil and water becomes mixed and it becomes a stable emulsion. So soap can reduce the interfacial tension between two layers. So this is done by the formation of micelles. So soap molecules can form micelles. This is the hydrophobic tail part of soap molecule. This is the hydrophilic head part of the molecule. So when a dirt particle is in a cloth, if we add soap solution to that for cleaning the dirt, what happens? The hydrophilic head part is soluble in water, and hydrophobic tail part is attached to the dirt or oil. If there is a oil or grease in the cloth, that tail part is attached to this, and these molecules, that soap molecule, form a micelle structure, and it carries the dirt particle away from the cloth through water. So soap molecule can interact with dirt or oil, that is organic component, and also it can interact with water through that head part. This property of soap having a ionic end and non-ionic end helps in the cleaning action of soap. This is a mechanism of cleaning action of soap. This is done by the formation of micelles. Then moving to the advantages of soap. As we already discussed, soap is made from fatty acid. Fatty acids are natural resources, so soap can be made from our natural resource. It is non-toxic, so we can say these are eco-friendly and biodegradable compared to detergents. Then moving to the disadvantage, soap is not applicable in hard water. Soap cannot produce lather in hard water. So soap can be applied only in soft water. In hard water, there is calcium and magnesium ions. If we add soap to that hard water, the calcium and magnesium ion reacts with soap and forms the corresponding calcium or magnesium salt of that fatty acid. That we already discussed, calcium and magnesium salt of fatty acid insoluble in water, and that forms a precipitate. That means if we add soap to hard water, the soap get precipitated as calcium or magnesium salt of corresponding fatty acid. These soap molecules have less cleaning property than detergents. It cannot be used in acidic media. In acidic media, the basic nature of soap is lost and soap becomes free acid. So free acid cannot clean the material because it does not have a hydrophilic and hydrophobic end. That is the reason for the cleaning action of soap. So soap cannot be used in acidic media. Also, soap is unsuitable for washing silk and wool because it contains excess alkali content, so it cannot be used for washing silk and wool.